Hello, I'm Dr. Dave Dubois, the state climatologist for New Mexico, assistant professor at New Mexico State University, and director of the New Mexico Climate Center. In this video, I will describe the different types of surface observation networks in the United States, their purpose, and what they measure. Our office manages 2 of these networks, so I'm really excited to share this information with you. Surface observation networks have many roles, such as for forecasting the weather, supporting the aviation community, collecting information on weather extremes, data for hazard mitigation as well as emergency management, climate change research, and agriculture, just to name a few. We commonly see these observations when we pull up a weather map of the country or when we see current conditions during a weather forecast from your local TV station. During the winter, water managers across the West look at maps of mountain snow in the hopes of a good surface water season. We're going to review the sources of data to put these maps together. One of the major uses of surface observation networks is to help forecast weather. We need observations of the atmosphere at multiple locations to initialize models. So in other words, if we want to predict the temperatures and humidity at 6 p.m. tonight, we need to know what it was at 5 p.m. and preferably several hours before that. Some of our weather models have become sophisticated, and so we need to know things like soil temperatures and how high the clouds are in order to make better forecasts. In the U.S., we have several observation networks, including those operated by federal, state, local, and tribal governments. The oldest running network is the National Weather Service Cooperative Network, which has around 10,000 stations throughout the country and dates back to the late 1800s. Another nationwide network supports aviation users and is called the Automated Service Observing System, or ASOS, and Automated Weather Observing Systems, or AWOS. These stations are located at numerous airports and military installations. The transportation sector also operates surface observation networks. For instance, there are networks of weather stations along our busy freeways that are called roadway information systems that assess the impact of weather on the nation's highways. If there is freezing rain or ice on the roads, we need to measure how much precipitation is falling and the temperature of the surface of the pavement. Some of them have cameras to monitor traffic, as well as to get a snapshot of the conditions on the ground. Weather observations are critical in fire weather community, and they routinely use another surface observation network composed of more than 2,000 remote automated weather stations, or RAWs, RAWS. These weather stations not only measure air temperature, humidity, winds, but also the conditions of the fuels that can potentially feed fires. Other networks are operated by state, local, and tribal agencies to support environmental protection and air quality management, and number about several hundred across the country. There is also the Climate Reference Network to track changes in climate. These stations are located in areas with stable land cover and land use to minimize the impacts of other changes over time. Surface observation networks are built of 3 main components: the sensors, data logging equipment, and the support equipment. In terms of sensors, most surface observing stations measure air temperature, humidity, wind speed, wind direction, and rainfall. For those used in aviation, we measure cloud height, their percentages, the present weather, such as rain, snow, the presence of nearby thunderstorms, or even dust storms. For those used in the agricultural sector, we need to know solar radiation and the state of the soils. So we have special sensors that measure soil temperature and moisture. This allows us to calculate how much of the water vapor is being evaporated from the soil as well as from the vegetation. The second part of a surface observation station is the computer that collects the electronic signals from the sensors and then packs them into one file so that it can be digitally stored. Most stations contain a weatherproof and ruggedized computer called a data logger that takes the sensor data and allows the data to be transferred to another computer or connected to the internet. In many cases, these observation stations are built to conform to standard practices and depend on the application. For example, those installed near airport runways need to be painted to make them visible from aircraft. Other practices include the height of the temperature and wind sensors from the ground. I hope that this short introduction to surface observations gave you an appreciation for what they are and then what kind of instrumentation is used. So the next time you look at a weather map, I hope you can appreciate what goes on behind the scenes and that it requires a lot of infrastructure, sensors, and maintenance.